Last year, generative AI became mainstream and it changed the way we thought about work. Suddenly, a realm of possibilities opened up which we never imagined. We all wondered, how is it that this simple-looking black and white interface responds to us better than most of our friends? GPT 3.5 showed us the power of natural language processing, and GPT-4 showed us how effective it can be in reasoning and analysis. Everyone who thought that AI will first affect those in jobs of physical labor and not the creative ones were in for a great shock. And all this happened at a rapid pace. It was an exponential leap for AI. But how did we get here? How did computers evolve from following basic instructions to guiding us with complex advice, sometimes even outperforming human interaction? The short answer is the evolution of large language models, or LLM. Every day, we interact with these models in ways we never even realize, from the virtual assistant on your phone to the customer service chatbot on your favorite shopping site. Large language models are the invisible force making sense of our queries and conversations. While we prepare for a new future, let's dive a bit deeper and try to understand from the first principles how a large language model works. Large language models are part of the broader field of generative AI, which in fact is part of an even larger field of artificial intelligence. AI, machine learning, and computer vision have been there for decades and they have been powering much of our digital applications. But what's different in generative AI is that computers can now not only process and smartly present existing data, but can also generate new data like humans. LLM is just one kind of a model in generative AI, and there are other models for handling videos, images, and sounds. LLM is basically responsible for generating human-like responses to questions or inputs. But before we get into the large part of the large language model, it is necessary that we first understand what exactly is a language model. By definition, a language model is just a probabilistic model of a natural language. In simple words, it is a computer program which learns from lots of text, what we feed to it, and then it uses machine learning to predict the next word in a sentence. Initially, the language models were of a purely statistical nature. For example, let's consider an early stage model known as the n-gram model. This model breaks the source text into chunks of n words, and so it is called n-grams. For example, in a 3-gram model, chunks are 3 words long, so it looks at the previous 2 words to guess the third word based on patterns it has seen before. The data on which it is trained is known as the corpus. So if the corpus of text data is, let's say, of a recipe book, the model might learn patterns like chop the onions or stir the mixture. So if it sees chop the in the inputs, it might predict onions as the next word because that's a common sequence in the recipe book data. When provided with a lot of different data sources, this model will find the next word based on how high is the probability of its preceding n-1 words of being in the entire dataset. During the learning process, the model is fed chunks of text created through a process called tokenization, and the chunks are called tokens. Each cycle of learning that the model completes over the dataset is usually referred to as an epoch. And with every epoch, the model tries to minimize the loss, that is, the failure percentage of generating the right word. To determine how the generated text should be, we have to specify a value called as temperature. Lower the temperature, more focused and deterministic text will be generated, while a higher temperature makes the responses more creative and random. But there is always a risk that if the model is overexposed or trained more than required on the same dataset, it becomes too repetitive and loses its creativity. Basically, it just memorizes the training data and can't generate responses for inputs it hasn't seen before. This is known as overfitting. Machine learning engineers always work on finding the right balance between training and evaluation. But these purely statistical models had limitations that prevented them from generating more nuanced responses. That's when newer models were developed, which were based on neural networks. A neural network is a deep learning algorithm which is somewhat modeled on human brain's network of neurons. It learns patterns and solves problems by processing inputs through various layers of interconnected nodes. At each layer, nodes or neurons receive a bunch of numbers as input and they output a bunch of numbers based on the parameters set in the model. The output of this model is then combined with the input and fed to the model again. As LLMs can have billions of parameters in its network, it's called large. This process is analogous to how detectives work. Detectives generally work to solve a mystery like a murder case or a robbery. In that process, they meet different people, visit secretive places, and collect a lot of clues. Sometimes they make deductions and test their hypothesis. If it turns out to be false, they work on a new set of data and generate new hypotheses and gather new clues. They keep doing this until they collect all the missing pieces to solve the case. When they move on to a new case, they use the learnings of their previous cases and start identifying patterns on the newer inputs they receive. So coming back to our neural network, how are the billions of parameters set in the network? This happens through a process called as training. To be specific, it's called unsupervised generative pre-training. Large language models like GPT-4 are trained on the whole of internet, including most books. During this training, the model keeps learning from the output and the parameters keep changing until the model starts to provide accurate responses. But they not only rely on unsupervised learning, they are also fed responses from real humans who evaluate the response. This is known as reinforcement learning. That's why ChatGPT never gives you a bad advice, though it can, but it is trained through reinforcement learning not to do so. One peculiarity of a large language model is that it uses transformer architecture. This came into existence when Google Brain presented their research paper. Basically, while processing inputs, the neural networks which are based on transformer architecture use a mechanism called as attention to weigh the importance of different parts of the input. This means it looks at various parts of the input text to understand its context and then use those weighings while determining the probability. This is why words in a response are generated in line with the context of the question asked. Behind the scenes, a team of linguists, machine learning engineers, data scientists work tirelessly fine-tuning these models to ensure they do not overfit and are not just smart, but also responsible and unbiased. It's a delicate balance, crafting a tool that's both incredibly powerful and ethically sound. Well, AI ethics is a big subject in itself and already discussions have started on it all over the world. But what you need to know is that the fundamental concepts of machine learning that were used previously in a language model, like the corpus of data, tokens, probability, epochs, loss, overfitting, all of these are used in the same way in development of LLMs. Only difference is that it uses the neural network and the transformer architecture, which makes its output sound like you're talking to a real human. So, that's how an LLM works at a very fundamental level. The leap from early basic language models to today's sophisticated versions is a brilliant display of human creativity and the continuous quest for progress. Each upgrade, more refined and complex, nudges us a bit closer to making human-machine conversations feel natural and intuitive. As we look at the future of digital advancements, we are not just seeing complex codes or mathematical formulas. We are part of the evolution of a new kind of intelligence, one that's poised to reshape our world in unimaginable ways. That's the incredible potential large language models hold for us. Do like this video and share with as many friends as possible. Also, please subscribe to Tinkerbrains for more such videos.